Hello and welcome to this lab lecture on resampling techniques. In this lecture we will create this document. At the beginning I present some general descriptions to you that you can read again what certain terms are meaning. Then we are loading our packages, importing the data, and we will perform at first some simple train validation test split and see how the training and validation performance is based on this simple approach. And after this we will work with cross-validation and we'll find out how to apply tenfold cross-validation and also another technique called leave one out cross-validation. And then we can finally compare all models. So that's our plan, and now we can start with the coding section. After you have downloaded the file from the homepage, you can extract it and you will find these files inside. So please click on the R projects file to start RStudio. And there are other files like the final file, which is including all code. But I would like you to follow me along and code with me. So please choose this template file. And this is loaded. At the beginning you can see the YAML section as always. Then I put some descriptions of several terms in here, just for reference if you want to read it afterwards. Finally, we are here at the coding section. We will start by loading the packages. We will need dplyr for the data manipulation, keras. We will need for the multi-assignment operator, which is part of the train validation test splitting function that we wrote by ourselves. And caret is the package that we'll use for the analysis of the modeling results and also for the modeling itself. So I click on the play button to run this chunk. Alright, so the next point is to import the data. We will work with our wine quality dataset. So this part is downloading the file from the URL. If the file is existing, it's read directly with read.csv. If it's not downloaded, then it's at first downloading. So it's only downloaded for the first loading. And then we create our data frame called df, which is including the downloaded data. So we run the complete chunk and see everything worked out. We have now here our data frame, which is having 12 different variables, and the final one, quality, is our target variable. So this is going to be some regression task. Okay, we will start with the simple train validation split. We will create some data frames called train validation test. And in here we will use the multi-assignment operator from the keras package, because our function train val test split that we wrote in an earlier section is providing 3 different objects, and with the multi-assignment operator these objects can be directly assigned to these 3 objects, train val test. What are the parameters required by train val test split? The first one is the data frame, that is going to be df. The next one is going to be the train ratio, which we will set to 0.6, and the validation ratio, which we define by 0.2, and the test ratio 0.2 as well. Okay, let's run this. You can see the objects are created, and we can create the model train. We will use the train function from the caret package And in here, the data will be taken from our train data set. The formula will be quality versus all other columns. And the method we will use is linear. So we are using a linear model to fit the data. Let's run this. And in the next chunk, we want to calculate the training performance. For this, we create a new column called train quality pred. And with the predict function, we can calculate the predictions. At first, we need to pass an object, which is our model object, model train. And the new data is stored in train. Okay, that works. And in caret are many useful functions. The one that we are using right now is post resample, which is requiring two parameters, a vector of the predictions and a vector of the observations. So let's define the pred object as first. The predicted objects are in quality pred, and the actual observations are in the column quality stored. And by doing so, we see that our R squared based on the training data is 0.3798. And now we want to do the same for the validation performance. So we create a new column in our data frame val. This is going to be called quality pred. And pretty similar, we will use the prediction function, predict function, and pass an object, which is the same, but the new data is now coming from the val object. And again, we can use the post resample function, where we pass the pred parameter to be val $quality pred, and the actual observations are stored in val $quality. And here you can see actually both are quite similar. I wrote in my description before the training and validation R squared are quite different and depend on the sampling of the data. So let's see in how far the sampling of the data changes the results. Keep in mind, both are quite close to 0.38. If I now perform the splitting again, this is inherently taking some randomness into account. And now we have different seeds and different data assigned. And now you can see it's already more differing. We can do it one more. Yeah, now you can see it's even differing more than before. So the result is very much depending on the splitting of the data. And you can try it and filter the data frame to only have a few hundred observations. Then the sampling plays an even bigger role. And then the difference of training R squared and validation R squared is even more differing than what we have here right now. So for this is one of the reasons why cross-validation should be taken. And we will use different objects right now. We call it train val, dummy, and test. We take our multi-assignment operator, call our function train val test split. The data frame is still df, but the ratios are different. The train ratio is going to be 0.8. The validation ratio is 0, and the test ratio is 0.2. And the reason for this is in cross-validation, you need to have only one object, which is having the training and validation both together implicitly. And there is no separate validation required. So this is the reason why I take this dummy object, which is not having any observations. So we just keep it in here for reference because it requires 3 different objects to be passed here. And the last one is the test object again. The result you can see here. Train val has now 1279 observations, dummy is empty, and testing is having 320. Now we come to the modeling part of cross-validation. And in here we can define an object called train control, which is a helper function. And we call here the function train control because in here we can specify many different parameters that define the splitting of the data, which resampling technique should be chosen, and all this is defined in this train control method. And the first parameter, if we go through the description of this function, is the method, and what we are going to use right now is CV for cross-validation. CV, and the next parameter is the number, because here you can see in the description number, this is either the number of folds or the number of resampling iterations. In this case it's the number of folds, so we need to define the number as well, which is going to be 10. Okay, that's enough for the object creation, and now we create a model 10-fold CV, and we use the train function from the caret package. We also have an object called train, so if you want to make sure that we use the right function, just use the namespace and specify the package name caret, then 2 colons, and then we refer to the function, which is train. And in here we can define the formula for the model fitting. We need to specify the data, which is train underline val, and the next parameter is tr control, and here we pass our train control object. And of course we also need to specify a method. Similar to what we did before, we want to fit a linear model to the data. Let's run the complete chunk. You can see it was quite fast. And we also can take a look at the model and can see here the R² for this cross-validation object. We reserved some test data, and now we can use it to create some new column called quality pred, and we will use our predict function where we pass the object model 10-fold CV, and the new data is going to be test. And then again we will use the post resample function to pass the predicted values, which is stored in quality under pred, and the actual observations are stored in test $quality. Let's run this, and we see that we have an R² of 0.3979. Okay. And the next technique is leave one out cross-validation. In the 101 lectures you have seen what this means. So every time there is all data used except for one observation for the modeling, and this one residual observation is used to be predicted. But you will see even for this very tiny data frame, the computational effort is quite high and the computational time is increased significantly. Again, we will create a new object, train control, and this is going to be fed by the function train control, but this time the method is called LOOCV for leave one out cross-validation. And we will create a model accordingly and pass here. Again, I will use the namespace carré colon train, and we will pass here our formula quality versus everything, and the data is going to be train var the control object is train control and the method is lm. This is going to take some time. Okay, here we are. The model was created and we can take a look at the result, which is stored in model LOOCV. The result for R squared is a bit lower than for the tenfold cross-validation. Also here we will create our predictions and see what the performance on the test data is. Now we will save some time and copy paste it from above and modify it slightly. We will call the new column quality pred LOOCV, and this time we are passing the leave one out cross-validation object, and also for the post resample we will use the quality pred LOOCV column, and we'll see what this will look like. So you can see the R squared on the test data is exactly the same as for tenfold cross-validation. So there is not much point in this case to make use of cross-validation. So I recommend to you to stick to tenfold cross-validation. That has also been established and is more or less the industry standard for resampling techniques. I don't see much point in using leave one out cross-validation, at least not in this case with this data. So that's it for this lab lecture on resampling techniques. Thank you very much and see you in the next lecture.